Welcome, my dear students. Now I am explain another important 8 marks question, that is, what is periodicity, how the following properties vary in a group and in a period. Explain. Atomic radius, ionization energy, electron affinity, either electron gain enthalpy, and last one is electronegativity. Here we need to write periodicity definition and atomic radius, ionization energy, electron gain enthalpy, electronegativity different definitions, and its vary in groups and periods also. Here now I am explain periodicity. The repetition of properties of elements at a regular intervals of electronic configuration is called periodicity, and this property is called as periodic property. That means the properties are changed from one element to another element with increasing the electron configuration at regular intervals. This property repeat itself is called as what? Periodicity property. Element to element properties changes takes place with increasing electron configuration. Repeat itself is called as periodicity, and this property is called periodic property. Here properties are what? They are properties. From that, first one is atomic radius. The distance between the center of the nucleus of atom to its outer shell or valency shell is called atomic radius. Simple definition: distance from nucleus to outer shell is called atomic radius. Atomic radius in groups from top to bottom increases. This is due to the differentiating electrons enters into the new shell. First, suppose first A group elements are what? Lithium, sodium, potassium, rubidium, cesium. Lithium outer shell is here what are 2s1, sodium 3s1, potassium 4s1. Outer shell configuration increases. That's why atomic radius is increase. In periods, from left to right, atomic radius decreases. This is due to the differentiating electrons are enters into the same shell and increases the nuclear charge. For suppose if you take a second period, lithium to neon, what happened? 2s1, 2s2, 2s2, 2p1 like that. Here the differentiated electron is moving in the same shell and increases the nuclear charge. That's why atomic radius decreases in periods from left to right. Next, what? Ionization energy. The energy is required to remove the electron from the outermost valency shell is called ionization energy. Electron removes from outer shell. For that, requiring energy is called as what? Ionization energy. In a group, ionization energy decreases from top to bottom due to increasing of atomic radius and decrease the nuclear charge. Just now I am explaining about atomic radius. Atomic radius is inversely proportional to I. That's why here in group, top to bottom, ionization energy is what? Decreases due to increasing of atomic radius. When atomic radius increases, nuclear charge is decreases. In periods, here ionization energy is increases from left to right because of decreasing the atomic radius and increases the nuclear charge. Very simple. In period, what happened? From left to right, ionization energy is here increases because of decreasing the atomic radius and increases the nuclear charge. Very simple. Now another property, electron affinity, either electron gain enthalpy. Here the amount of energy is released when I add a electron to the outer shell of an atom is called as electron affinity, either electron gain enthalpy. Once again I will repeat for you. What happened? The amount of energy is released when added a electron to the valency shell of an atom is called electron affinity. Energy is released when addition of electron to the outer shell. Simple definition. Here this electron affinity in group from top to bottom decreases due to here increasing of atomic radius and decrease the nuclear charge. Similar, here this electron affinity is also inversely proportional to the atomic radius. Atomic radius is here increases, that's why electron affinity decreases. When atomic radius increases, what happens? Nuclear charge is here decrease. That's why electron affinity is also decreases from top to bottom. In periods from left to right, here electron affinity is increases because of atomic radius is decreases, and here increases the nuclear charge. Electronegativity. The tendency of an atom to attract the shared pair of electron towards itself is called electronegativity atom, and the property is called electronegativity. For suppose I am taking an example H2O. Here this bond contains shared pair of electrons. This shared pair of electrons are attracted by the oxygen. So here oxygen is called electronegativity element. That property is called electronegativity. That's why here the tendency of an atom to attract the shared electron pairs towards itself is called electronegativity. Here electronegativity in groups from top to bottom is what happened? Decreases due to increasing of atomic radius and decreasing the nuclear charge. This electronegativity is also inversely proportional to the here atomic radius. Atomic radius is increases, that's why electronegativity decreases. In periods from left to right, this electronegativity is what increases due to decreasing of atomic radius and increase the nuclear charge. Look here, very simple. Here in groups only atomic radius is increases, remaining ionization energy, electron affinity, electronegativity decreases. Here vice versa in periods. In periods what happen? Atomic radius decreases, remaining three properties are increases. If in examination electropositivity will come, here that answer is quite opposite to the electronegativity. Here the tendency of an atom donate the shared pair of electrons to another element is called electropositivity. In groups what happen? Here opposite. Here in groups here electronegativity here decreases, that's why electropositivity increases. In periods electropositivity is what happen? Decreases. Okay. Now if another property also here asked sometimes, that is what nature of oxides. Nature of oxides in groups, here what happened? Its basic nature increases, basic character increases down the group. Here in periods from left to right, acidic nature is here increases. Here this is a regular repeating question. Here periodicity and its properties. Thank you very much. Dear students, now I am explaining another important 8 marks question, that is write an essay on the division of elements into spdf blocks. Simple answer. Based on the differentiating electrons enters into various atomic orbitals, elements are classified into 4 blocks. They are S block, P block, D block and F block. Here differentiating electron means what? Lost electron. If enters into the S subshell, either P, D, F, elements are classified. Here now S block elements. The differentiating electron is enters into the S orbital. Such elements are called S block elements. S block elements are located at the left hand side of the periodic table. Look here, left hand side of the periodic table. Here S black elements general electron configuration is NS2. Here S black contains two groups. They are 1A. 1A is called alkali metals, and 2A is called alkaline earth metals. These S block elements are what are highly electropositive in nature and soft metals. The differentiating electron enters into the p orbitals are called p block elements. Last electron enters into the p orbital. Such elements are called p block elements. Here p block elements are located at the right hand side of the periodic table. Here the general electron configuration is NS2 NP 126. Okay, NS2 NP 126. Here it contains 6 groups. They are from 13 group to 18 group. Here are 13 group to 18 group. The number of groups are 6. That's why here electron configuration after the NS2 NP126. These p block elements are mostly non-metals. Some are metalloids and few elements are metal. D block elements. The differentiating electron enters into d orbital. Such elements are called d block elements. Now the differentiating electron enters into where? Into the d orbitals. Such elements are called d block elements. The general electron configuration is n-1d 1 to 10 ns 1 to 2. N-1 means the d orbital is present in penultimate shell. Penultimate shell means what? Before the valency. Valency is n, that's why this here penultimate n-1. So electron configuration is n-1d 1 to 10 ns 1 to 2. This d block elements are located in between s and p block elements. Here look here clearly, in between the s and p block elements. Here these groups are from group 3 to 12th, because of you learned before s black number groups are 2, p black from 13 to 18. That's why in between them here 3 to 12 will come. Here these d block elements showing various characters. Here they are, such characters are what? Like variable oxidation number. For suppose iron shows +2 +3, manganese shows +2 to +7. That's why that shows variable oxidation number. Colors nature, color nature. Here d block elements shows colors. For suppose blood, iron, red color. Here copper, blue color, manganese, flesh color, etc. etc. Here magnetic in nature. Iron, cobalt, nickels are what? D block elements, they are showing magnetic nature. F block elements. The differentiating electron enters into the F orbital. Such elements are called F block elements. Here outer electron enters into F orbital. Such elements are called F block elements. The general electron configuration is n-2 F 1 to 14, n-1d 0 to 1, ns2. Here n-2 means pre-penultimate shell, just before the penultimate. That's why n-2. Here F orbital filled with 14 electron. That's why F 1 to 14. n-1d 0 to 1. Only one element there. That's why 0 to 1. Here ns2. So simple electron configuration is what? n-2 F 1 to 14, n-1d 0 to 1, ns2. These F block elements are placed at bottom of the table. Here bottom only. Here it contains two series. There are 4F series called lanthanides, 5F series called actinoids. Generally, here F block elements are showing a +3 oxidation number. Thank you.